Okay, listen. As I said a minute ago, okay, I think I said this a minute ago. I really do not care if you, after this class, go into college and then take subsequent classes where you have to use calculus. I think it's a great choice if you do that, because that was my choice. But you don't have to. Like, you don't offend me if you choose other majors. I want you to choose what you want to study. But I am convinced you can't find a better class in high school than this one to prepare you for college. It has nothing to do with calculus. Nothing. It has everything to do with developing the right study habits so you will be successful in college. Getting away from memorizing, focusing on understanding. I had a student several years ago now, 6 or 7, sat right here, B6, okay? She worked really hard. She was not very successful in calculus, okay? However, she wrote me an email after being at Utah State for like the first semester. The email was really interesting. She was just a little thank you. She said, look, thank you for helping me in calculus. I took psychology at Utah State, and I noticed that like just a couple weeks into the class, everyone around me was complaining. We don't understand. The quizzes don't make sense. They don't even correlate. And the quizzes don't correspond to what we're learning in class. Blah, 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 all those kind of complaints. The teacher's like, the teacher will have none of it. Okay? Get used to that in college. Okay? The professor's rule, like, you can't complain. There's nothing you can do about it. But the thing that students were missing, that my student didn't miss, was all of those students were still trying to just memorize stuff. Emily, was her name, she had learned from calculus that she had to understand the material. She was doing just fine in psychology. Okay? Like, that's what I'm trying to help you do. So here's another example of that. We're supposed to find values of A and B so that the function is continuous. Okay? There's quite a bit of information we have studied about what it means for a function to be continuous. I'm going to review that right now really quick. This should all be in your notes. Really, you should all already have flashcards for this, but if you haven't, here they are. Okay, first thing I would remember is this. And again, I don't flashcard anything until I understand what I am flashcarding. In some cases, if all you remember is a function is continuous, as long as you can draw the function without lifting your pen, that's enough. You can answer AP questions that's all you have to know. So one simple definition of continuity is, I can draw the function without lifting my pen. That will suffice for some AP problem. But some problems are going to say, they're going to require you to think about, well, what are the different types of discontinuities? And you've got to go, oh yeah, jump, removable, vertical asymptote. That's not new, we studied that. Then you've got to say, well, how do I know whether there's a jump, removable, or vertical asymptote? Visually, that's easy. You just look at it, you can see what they look like. There's lots of examples in the homework. But in some cases, you're going to have to use this. Okay, copy this down, 1 second. There it is. So this is also from your homework. This is not new. A jump occurs when the limit from the left is different than the limit from the right. So that's the first thing you check for. You have to know that. It has to be memorized. If you identify that there's not a jump, then you know that the left and right limits are the same. So now you compare the overall limit, which is the same as the left and right, to the value of the function. If they don't match, you have a removable. Okay? Now, another way a removable occurs, or another way to identify the removable, is you plug in an x. This is very much related to Kylie's comment on vertical axis. So Kylie's scoring, there's 2 more. It's all kinds of points today. It's just her day. It's Kylie day. All right. Okay, look. If x is 8, you plug in the 8, and the y value you get is 0 over 0. That's a removable discontinuity. So you have to know that. But when this occurs, this will occur. They're synonymous. The left and right limits will match, but they will not match the value of the function. Okay? These are my boys. Questions? We want to talk about that more. If the left and right limits are the same, and that means the overall, and they match the value of the function, then the function is continuous. This item in pink is just another way of saying a function is continuous. You have to know that definition. I gotta get some water. We want to talk more about that. Okay, excuse me. Okay, so that's what you have to understand, and then flashcard. Anyone want me to talk specifically about anything? Ashley, please.
So, so it's continuous at a certain x value, the left limit and the right limit and the y value are all the same.
And in reality, Ashley, this right here is, okay, I'm about to say something that is not 100% mathematically correct, but to me it's close enough to help you understand. Okay, because there are an infinite number of points, Ashley, I keep saying your name so you get more points. You can't zoom in and ever see the points. Like no matter how close you get, you can never see them. But that's hard to think of. So I just pretend I can. I'm like, hey, if I zoom in, I can see the middle point. And I can see that it has a y coordinate of maybe 7. Okay? If I zoom in really close, I pretend I can see the point that is just barely to the left. And if I see that that y coordinate barely to the left is really close to 7, and the y coordinate that is barely to the right is also really close to 7, that's what makes the function continuous at x equal 3. Finding this limit is very much like finding, it's not exactly but close enough, this y coordinate. Finding this limit is very much like finding this y coordinate. And that's why when these three things are the same, the function is continuous at x equal 3. Is that what you meant?
Yeah.
It's really well done, Ashley. Anyone else want to talk more here? Okay, look. So if you read a question like number 1, and again, hey, listen. When you look at question number 1, you are telling yourself over and over again, I'm not trying to solve, like when you do the homework, you've got to keep telling yourself, I'm not going to solve the problem by remembering another problem. I solve every problem by remembering my flashcard concepts, okay? If you're stuck here, it's because you have not spent enough time with flashcards. Like you're reading the word continuous, your brain's just drawn a blank because those flashcards have not been imprinted on your memory. Once they're imprinted, then you can make some progress because you say, okay, this is supposed to be continuous. Let's see. It's piecewise, so it could have a jump. It can only have jumps, though, at the transitions. So that would be x equal 2 or x equal 4. I'm not going to have a jump somewhere else. Please.
What was the rule? Like, if it's not piecewise, they can't be a jump?
No jump. Yeah, for our class, not piecewise, no jump. 2 for Josh. So the function is supposed to be continuous. Maybe it has a jump at x equal 2 or x equal 4. It's not going to have a vertical asymptote because I can't plug in an x and ever end up with a y that is something over 0, because none of these formulas will ever become something over 0. We want to talk more about that.
That one has like no division.
There's no division. There's no way to get the bottom 2 become 0. Vertical asymptote. So I'm like, okay, let's focus on, could it be a removable still? But remember the notes here. Remember your flashcard that said this. Right here. Come on. Copy this page. So remember that we check, we know there's no vertical asymptote. So we need to check for a jump first before we even think about removable. So back to here. I check for a jump by checking the limits. So here, let's do that. So the limit, as x approaches 2 from the left, again, hey, on the test, no one's going to check your notation. You're using good notation for 2 reasons. One, you may have to go back and look at this and remember what the heck you did. Okay? Otherwise, it serves no purpose that you ever even did it. Like, you've got to know that, how did you do it? Look at the real world over there. Look over there. Okay? The only way to make something that sophisticated is you have to document everything. Because human beings can't remember. So like at my little company where I work, 50 people, gigantic room with like 3 gigantic file drawers, just full of documents like that. Because you can't remember. It's like a huge part of your job is documenting what you have done, so when you come back to it 2 years later and you want to improve on the design, you can remember what you did. The same thing is true in here. Exactly the same. Okay, so I find this limit. It means x is a little bit less than 2. So I put it in here. This is going to be really close to 9. Find the limit as x approaches 2 from the right. That means I have to use this formula. Okay, that's going to be really close to 4 plus a. I just figured out that a is 5. If the function is going to be continuous, the 2 limits must match. A has to be 5. That's how you solve a lot of problems. You don't solve them by knowing how to solve them. You solve them by referring to your flashcard memory, working on that, and then suddenly the answer just appears. So, you would solve for b the same way by just finding the limit as x approaches b for 4. So we say limit as x approaches 4 from the left. See, that's going to be 16 plus a. The limit as x approaches 4 from the right. That's going to be, let's see, 4b plus 9. Oh, but I know a is 5. So 16 plus 5 has to be the same as 4b subtract 9. Standing in someone's way, sorry. Trying to get close to the board. Plus, thank you. 2 points for Sarah. 21 subtract 9. Anyone want to talk more about that? And again, please, 1 second, Chris. Hey, you're sick of me saying it, but I still see people doing it. They look at that and they go, I know how to do that problem. And I say, useless. Do you understand the concepts I used to solve the problem? And can you memorize those concepts? Please, Chris.
Yeah, so to find like the limit of A, I'm plugging in
The limit of what?
something the limit of A to find the Y. To find the Y, am I plugging in something that's really, really close to -2?
Yes.
Really close to +2.
That's what limit, hey, 2 points for Chris. That's a really good example of another thing you must understand. What does it mean to find a limit? Finding a limit means you're just plugging, this is what I said to Ashley. Plugging in an X and you're finding a Y. So I'm plugging in a value that is extremely close to 2, but slightly less. And I'm trying to determine what is the Y coordinate when I do that. And I find out that the Y coordinate is extremely close to becoming 9.
And then on the second one though, on X, when I'm plugging in something that's really close to above 2, I get, if you get 4 plus A, am I trying to like to find what 2 actually is? Or
We didn't write it down. To be continuous, I would have to. I'd have to say, what's f of 2? This is Ashley's comment again. Look, more points for her. F of 2, I would have to use the top formula. That's going to be
okay.
exactly 9.
Yeah.
These 3 right here, these 3 red boxes must be exactly the same for the function to be continuous. That's the definition right here. Oops, right there, sorry. That's the definition. All 3 must be the same. So I want to make the function be continuous. I want to make this definition work. To make the definition work, I must choose an appropriate value of A so that the red boxes are all the same.
Yeah, and look at how you got 5.
So are you okay that these 3 red boxes must be the same?
Yeah.
So if 4 plus A must be 9, what value must A have? So 4 plus
5.
A has to be 9.
5.
5. Other things you want to talk about here? Look, I mean, you see when I give a lot of compliments is because I can tell that you are probing for understanding. That's why it's Kylie's day, okay? Sorry, she's embarrassed now. I kind of get the sense you're okay with that as long as I keep saying, as long as you keep picking up your pencil and marking it down. Okay. Making sure I don't want to. If you'd like me to stop, I will stop. So, yeah, her question was right on. Like it wasn't, how do I do this problem? It wasn't, what are the steps? I don't remember the steps. It's like, we don't talk about that here. It's like, what is the concept? So, anybody else want to talk here about any of it? We got 3 minutes. You would have another specific question.